It's out of England. It's a company over there called Revolution Education, and they put bootloaders on microchip PIC chips of different sizes. It's a real simple system, programming basic, no library fed in. Now, we know you've got open source. You come across something you can't interface, chances are there's a library out there you can download and deal with it. With this, it's proprietary, so you've got what you got. There's a lot of stuff in the language, but if you come up on something that's outside of the language, you're either going to have to figure out a way around it or do it a different way. But there's a lot of stuff in there. We have a slide, please. Okay. Oh, yes. We'll get started. Anyway, most all of the PicAxe chips have the capability to play a ringtone, just fairly simple. And this is how you have those speakers hooked up and sit between the pin and the ground. If you use a regular speaker with a magnet in it, you're going to have to put a resistor in there to keep the current down, because big pins are only 20 milliamps, something like that. Give us another slide, please. Okay. Now here we've got, a sampling. This is pretty much the current parts that PicAxe is selling. Goes all the way from 8 pins to 40 pins. Your part numbers, obviously. Whoa, what happened? Where'd we go?
You've done it.
There we go.
All right, cool.
Sorry.
Anyway, obviously your part number, the number is going to be your number of pins. Now when I first started out, it was just a number of pins. And now we've got the M series and the X series. There's an X1 series that's been superseded by the X2 series. And supposedly, real soon now, they're coming out with an 18M2 that supersedes this, which is supposed to be real cool. But not having gotten my rubbing little paws on one yet, I don't know. Now, 8Ms, well, that's what we used on the data logger for the balloon. It's a tiny little chip. You got 256 bytes of memory to play with. There's a lot of things you can do with it. This is one of my favorites here. It gives you a few more pins to play with. Gives you a pulse width modulated output so you can run a motor and do fun things with it. And then, of course, you got bigger stuff. You've got the 28X2, which gives you as many pins as an Arduino, and the 40X2, which is basically the same thing, only with more pins. Go ahead and give us a little slide.
I'm sorry, these chips are their own PicAxe, not microchip.
It's made by microchip. It's just a standard PIC part, and they've got a bootloader loaded into them that lets you go to the basic program release. This is your download circuit here. All you really need is 2 resistors, and I don't know how well you can see, but just you're coming off 3 pins on your serial port. Now, if you have a USB port, you're in a little bit more trouble. You got to buy an adapter with a USB to serial chip in it. The one that the Revolution Education sells is, I believe, $27. Spark Fun has one you can pick up for $15. But this is my cable that I made, and I was able to put all the resistors up inside the hood on the serial connector. So, come on, solder 2 resistors, 3 wires, no big deal. Now, their standard, and I don't know how they came on this standard, but their standard connector for programming for PicAxe boards is a stereo headphone jack. Since it's 3 connectors, kind of makes sense. What I usually wind up using is something more like this, just a 3-pin header, because I do a lot more work on breadboards, and I can just stuff that down in there and hook it up. So when you get it lined up right, it's no big deal. For some reason,